When you first start building an AI application, it's common to assume the entire process is just taking a provider's SDK, a software development kit used to interact with their models, and hooking it up to a user interface. This direct prompt-in, response-out workflow handles simple queries effectively. However, the requirements of production-grade software engineering quickly outpace this basic connection. A raw API call lacks a persistent memory of previous interactions. It cannot natively read your private documents, nor can it trigger external functions like updating a database or executing a transaction without extensive custom code. Systems built solely on these basic provider APIs remain fragile and struggle to handle the multi-step complexity required for enterprise-level applications. Real-world AI applications rely on a hidden infrastructure. A single user query often splits into a sequence of events. It hits a document parser to extract text, then a vector database, which stores information based on mathematical similarity rather than keywords to find relevant context before finally reaching the large language model. Tightly coupling every retrieval and parsing step to one provider's proprietary model creates a significant dependency. If you build your entire logic around their specific API, your software is effectively locked to their ecosystem. This creates operational risk. If that provider raises their prices or changes how their model processes data, you face the massive, time-consuming task of completely rewriting your entire backend just to migrate to a new vendor. Developers use an abstraction layer to maintain independence. This layer allows them to swap out individual components and scale their systems without being tied to a single provider's roadmap. Orchestration frameworks function as the management layer sitting between the application and the raw AI models. Toolkits like LangChain and Llama Index handle the complex logic of integrating custom data. They provide standardized modules to connect different data streams to the model, removing the need to write custom integration code for every new document or database. These frameworks enable multi-agent workflows, where different AI instances collaborate on tasks, and allow for model-agnostic development. You can switch from one provider to another by simply replugging the framework into a different node, while your app stays online. Orchestrators convert AI from a static, dependent API call into a modular system that developers can modify and expand. While orchestrators manage how models interact with data, building or training a model from scratch requires a deeper layer of deep learning frameworks. Google's TensorFlow is the primary choice for large-scale, enterprise-grade production. It handles the massive computational loads required to deploy AI across global infrastructures. PyTorch is the standard for academic research and rapid prototyping. It utilizes a dynamic computational graph, which allows researchers to change how the model processes information during execution, making it easier to debug and iterate. Hugging Face provides the central toolkit and repository for accessing these models. It allows developers to download, fine-tune, and deploy open-source models without relying on a third-party API. These core engines provide the mathematical environment that allows independent AI systems to function both locally and securely. Running these models constantly on cloud servers introduces a final bottleneck: high operational costs and network latency. Edge deployment solves this by running optimized models locally on an AI PC. This brings the intelligence directly to the user's hardware. Hardware-level frameworks like Intel's OpenVINO toolkit compress models, efficiently distributing workloads across the CPU, GPU, and NPU, the neural processing unit built for high-speed AI tasks. Once optimized, Microsoft Foundry and WebNN execute it on local silicon, bypassing the cloud entirely. Using hardware-level frameworks ensures that AI applications are economically sustainable, private, and capable of near-instant response times. The modern AI ecosystem is a layered hierarchy where each tool addresses a specific engineering hurdle. In the foundation layer, the rule of thumb is to use PyTorch for prototyping and research while relying on TensorFlow for enterprise scaling and high-volume deployment. For the application orchestration layer, LangChain or Llama Index provide the necessary tools for connecting custom data and building complex conversational agents. Identifying the correct framework for a specific architectural bottleneck is the core skill of a modern AI engineer. Mastering this stack allows developers to train models in the cloud using open tools and deploy them seamlessly to the edge. These frameworks provide the technical structure that transforms raw mathematical algorithms into the robust, scalable software required for the real world.